Hi everybody. So in this video, we're going to look at sigma notation for sequences and series. So in example 1, we'll look at an arithmetic series, and in example 2, we'll look at geometric. In example 3, we'll work through an exam style question. So if we begin with example 1, this symbol means sigma. This is the sum of its discrete terms. Of all the terms in this series, between the first to the sixth term. So the way we find this is we let r equals 1 and we work out the first few terms. So when r equals 1, we've got 4 minus 1.5. So this will be 2.5. When r equals 2, we've got 8 minus 1.5, so 6.5. And when r equals 3, we've got 12 minus 1.5, so 10.5. And we're adding all of these together, okay? All the way until r equals 6. And this will be 24 minus 1.5, so 22.5. So the way we can evaluate this series is we can use the standard formula for the sum of a series, n over 2 multiplied by 2a plus n minus 1 d. A is the first term, d is the common difference, and n is the number of terms. So the sum of the first 6 terms, well, n over 2, this will be the 6 divided by 2, so 3. 2a is 2 lots of this first term, so this will be 5, plus n minus 1, which is 5, and the common difference you can see is 4. So we can work out this bracket. We've got 5 plus 20, so we'll get 3 multiplied by 25. So our first 6 terms will have a sum of 75, okay? And then for part B, now we need to work out the sum of the terms between the 7th term and the 50th term. So if we write this as between the 7th to the 50th term, this will be the same as between the 1st to the 50th term minus the sum of them first 6 terms of that same series. So we work out the sum for the 50 terms, we take away the first 6, and what we're left with is the sum between the 7th to the 50th. And we've already worked this one out as 75. So for the terms between 1 to 50, we know that n is 50. This will be 50 divided by 2, again using this standard formula, multiplied by 2a, which is again 5, plus n minus 1, and the common difference is still 4. So we can work this out as 201. So it'll be 25 multiplied by that 201. And this works out as 5,025. So the sum between the 7th and the 50th term of our series will be the first 50 terms minus the sum of the first 6. And this works out as 4,950. Okay? In example 2, we're going to look at the sum of a geometric series using sigma notation. For question 2, now we're looking at a geometric series. So we'll go through the same process. We'll work out the first few terms. When k equals 1, we'll have 4 times 2 to the power of 1 take away 1, so 2 to the 0. This works out as 4. When k equals 2, we'll have 4 multiplied by 2 to the power of 2 take away 1, and this is 8. And then when k equals 3, we'll have 2 to the power of 3 take away 1, so 2 to the power of 2. and this works out as 4 times 4, which is 16. And then we would carry on all the way to k equals 10. And this would be 4 times 2 to the power of 10 take away 1, which gives us 2048. So now we've got our geometric series, we know that the common ratio is 2, our first term is 4, and the number of terms is 10. So we can use the standard formula for the sum of a geometric series, which is a lots of r to the n minus 1 over r minus 1. So we'll substitute in our values. We've got 4 multiplied by r, which is 2 to the power of 10 over the 2 minus 1. So we can work out this numerator and we get 4092. Okay, so that's part A. For part B, now we're only looking at the sum of the terms between the third term to the 10th term. So we can write this as between the third to the 10th term will be 4 times 2 to the power. This will be the same. What terms do you think we're going to look at in this summation? Right, so this is k equals 1 to 10 of that same geometric series. What do you think we need to take away from this to get between the third to the 10th term? So we only need to take away when k is 1 and k is 2. So we need to take away the 4 and the 8. We just need to take away the 12. And we've already worked out this first bit. This is 4092. And when you take away the 12 from this, we get a sum of 4080. Okay? Let's try one more question. Okay, so for example 3, now we've been given the summation between the first to the kth term of 5 times 2 to the r, and we're given that the sum is 5110. We need to work out the value of k. We need to show that k is the log of 512 over the log of 2, and then to use its value of k to work out this summation. So perhaps you want to give this question a go yourself. You can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back if you want to go. So we'll work out the first few terms. We'll substitute in when r equals 1, and we get 5 times 2 to the 1, so this is just 10. Then we'll substitute in r equals 2. This will be 5 times 2 squared, so 5 times 4 will give us 20. We'll substitute in another one when r equals 3. We'll get 5 times 2 to the 3, so 5 times 8, and this will give us 40. And then we'll carry this on all the way to r equals k. This will be 5 times 2 to the k. Okay? Well, we can see we've got a geometric series. We know the first term is 10. We know the common ratio is 2. And we're looking at k terms. So we'll use the standard equation. We get a times r to the n minus 1 over r minus 1. So we've got the sum to the first k terms is given as 5110. A we're given as 10. And r to the n will be 2 to the power of k minus the 1 over 2 take away 1 is just 1. So now we need to rearrange this to work out k. So we'll divide both sides by 10. We get 511 will be 2 to the k minus 1. We'll add 1 to both sides. And then to work out k, we need to take the log of both sides. So if we take the log of 512, we can use the power rule to bring this k down. So this will be k times the log of 2. and we'll divide both sides by the log of 2. So the log of 512 over the log of 2 will give us k. Okay, and that's what we were asked to show here. We can work this out, and we get k is equal to 9. Part B, for this value of k, work out this summation. So what we need to find is the sum of all the terms between k plus 1, which is going to be 10, to 12, of 5 times 2 to be r. So we only need to look at when r equals 10, r equals 11, and r equals 12. Well, when r equals 10, we've got 5 times 2 to the 10. When r equals 11, we've got 5 times 2 to be 11. And when r equals 12, 5 times 2 to the 12. So we can work out each of these. We've got 5,120 plus 10,240 plus 20,480. Then we can add up each of these and we get 35,840. Okay? Well, thank you very much for watching. I hope that's given you a clearer idea on how we can work with sigma notation for arithmetic and geometric series. If you found that helpful, please like and subscribe, and you can download a full lesson and a PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.